Without further ado, let me introduce our speaker today. So the talk today is by Abi, who is at Flexport. Abi is a growth and analytics leader who currently leads product-led growth, product analytics, and analytics engineering at Flexport. He's had great experience in the data and the growth space in the past, working at Keep, Hustle, and Honeybook. Today, he's going to be chatting with us about modern data team and what it takes to organize and a team around the modern data stack and how and its impact on how we work. So with that, I'm going to pass it on to Abi.
Thanks, Mark. Everyone can see my screen okay?
Yep.
Okay, all right, let's get started. So I will kick off here. So hi, folks, I'm Abi. As Mark said, I'm currently at Flexport, where I head up growth and analytics. I've been at Flexport for about 3.5 years, and then have seen a tremendous amount of growth at Flexport. I think we've grown our overall data function 5x. We've basically 2.5x the size of the company. Seen many eras of data here in the past 3.5 years. And yeah, today looking forward to sharing some of how we think and how we've approached that scaling journey on both the data team and the company at large. So we're going to talk about data teams today. That is a big, huge topic, and I'm not going to touch most of it. Right? I'm not going to talk about things like central versus matrix, or how we prioritize, or anything like that. What I'm going to be focused on is instead, irrespective of how you structure data teams, irrespective of how you orient them, what are those core functions? What is that core set of functions that need to be represented, and how do we position them? And how has that process, how are those considerations, how have they changed over time? And most notably recently with the advent of the modern data stack. So that's really where we're going to focus, and we're going to zoom in on one function in particular for the interest of time, and we're going to zoom in on analytics engineering. So with that, first disclaimer is there is no ideal data team. That's an important call out. One of the tough things about the data world more broadly is that there really isn't a standard and universal set of best practices, right? There isn't a best practices Bible out there. And it's something that practitioners throughout the industry have always tried to call together, but it's tough. There aren't many categorical imperatives for how we should work with data. And we have to qualify most of the advice we give to each other with, your mileage may vary. And the reason for that is really that context varies, right? Your context might vary. The right org design, what functions do we have? How many of them do we have? How do we position them? All of that depends on context. And really three types of context. Company context, industry context, and tech context. So company context is, hey, how big is your company? How mature is it? How complex is it? What is the rest of the org structure like? The industry context is, I'm in freight forwarding. I'm in the logistics space. What kind of use cases can really be supported by logistics? What kind of data use cases can be supported by this industry? What kind of data do we have? Is it large in volume? Is it wide in scope? How is that data structured? Is it structured or unstructured? And the third context is where we're going to focus, and that is the tech context. And there is there's a reason we're going to focus on the tech context, right? Number one, it's what we all share, right? We don't all share the same industry context or company context, but we all definitely share the same tech context in the broader data tech landscape. And it's really what's changed the most by far, right? I mean, even in the time that I've been here at Flexport, 3.5 years, the data landscape has accelerated dramatically, from what was hot in BI, what was hot in data transformation, and how large DBT was in the community, 3.5 years ago to where we are now. It's night and day. And it's why so much of the oxygen in the conversations that we have in the community, in the data community water coolers we have, goes to data tech. It's what we all share, and it's really what has changed the most. So if we're going to talk about data tech, we have to talk about the modern data stack. And folks, I really tried not to use, I tried to avoid two words, two phrases here. Tried to avoid modern data stack, and I tried my best to avoid data mesh, and I'm going to say both. So apologies in advance. But we really can't avoid putting the modern data team in the context of, the much memed modern data stack. And I get the critiques of the notion of an MDS. I think they're for the most part apt, but there's clearly something happening here, and there's clear investment theses that are driving all of this money and human capital and whatnot into data tech right now. And look, I don't have the most comprehensive framework, the most comprehensive theses on MDS, but how I reason about MDS and what it implies is as basically 6 forces, and those are the forces we see here. Number 1, low-tech ingestion. 2, centrality of the warehouse. 3, diffusion of data transformation. 4, the introduction and build out of metrics and semantic layers. 5, the rise of data ops. And 6, the continued democratization of science applications. And so, for each of these, we'll just run through to kind of kick off here before we talk about teams. We'll talk about, what these represent to me, what I think they imply, and we'll file those implications away as we and revisit them as we think about what it means for our teams. So we'll start with low-touch ingestion. Look, pretty straightforward. It's just never been easier to ingest data. Whether it is a streaming or a batch source, whether it's a proprietary source or a third-party source, whether it's a database or an event, it's never been easier. It's never been lower friction. No touch, low touch, very low friction at any rate. And the implication here is clear, right? The implication here is, data engineers shouldn't write ELT pipelines. Of course, what I'm citing here is the famous Jeff Magnuson post on Stitch Fix's blog that engineers shouldn't write ETL. But to put into context, that post on Stitch Fix's blog, multi-threaded, that was in 2016, and at that point, that wasn't so long ago. And in 2016, that post struck a clarion call, resonated with the space, but it was still more aspirational, right? It was still not something that most teams could realize. And that has changed, right? In 2016, I think Fivetran, most of these tools were not very big or hadn't developed to the extent that they have today. I think Fivetran was 3 years old, and we were just very far from being able to realize the notion that data engineers should not actually write these pipelines and own them end to end. But that has changed. And so what that means for us is that, now is the time we can and should definitively minimize the importance of this kind of responsibility, the EL aside, especially, right? Owning the EL pipelines within our teams. And wherever we can, wherever it makes sense from a governance perspective, wherever appropriate, to actually distribute the responsibility entirely. So it's not just a person with data in their title that actually has to flip the switch, has to press the buttons, to get data flowing through the pipes on Fivetran or Stitch or Airbyte or what have you. Great. So that's the first theme. The second theme is the centrality of the warehouse. So look, the warehouse is now powering more, right? The MDS, the modern data stack, whatever this means to us. One of the things that's very clear is that the warehouse is playing a more prominent role in applications throughout the enterprise and value throughout the enterprise. The warehouse always powered BI use cases, but now it increasingly powers production ML. They had always powered analytics use cases, but now it powers operational use cases as well, with the rise of reverse ETL, where we send data back to source systems, the new kind of data activation push and the customer engagement platform pushes of tools like Supergrain. So now driving increasingly operational use cases as well. The warehouse always received data from other applications, but now it is increasingly the very back-end store for those applications, right? The rise of these native data warehouse native applications that use the data warehouse as its data store. And so in keeping with all of this, the warehouse, whatever we call as a warehouse here, is the center of, well, certainly the center of the data tech ecosystem, but it's also increasingly the center of data value creation within the company writ large. Right? And it's a very clear sea change for us. And the implication is also clear that if the data warehouse was valuable before, it's more valuable than it's ever been. The data warehouse is absolutely, if you want to drive value in the enterprise, it's absolutely now the most critical, the most high leverage point of focus for data teams. And this too wasn't always the case, right? Again, historically, if we go back to, if we anchor on that 2016 date from a few minutes ago, look, at that point, the warehouse was still primarily powering analytics use cases, right? Not so much these operational use cases. Interactive data applications were still a fantasy, and production ML use cases were, occasionally powered on the warehouse, but often were powered on separate systems. So, these are recent changes that have really catalyzed the importance of the data warehouse. And now the data warehouse is one of the most important investments a data team can make. 3, the diffusion of data transformation. So look, I mean, this is essentially that, in a world where we've lowered the barrier for data transformation tremendously, there are simply far fewer good reasons why, companies shouldn't incentivize, shouldn't expect functions throughout the company, right? PM functions, design functions, engineering functions, et cetera, to contribute to the task of data management and processing, right? And this has been enabled by transformation being easier than ever. SQL is the ascendant lingua franca, right? Either is a lingua franca and it will be, or it will be the root language that the next lingua franca will be built on. As much as we talk about, SQL versus Python, SQL has basically won. It's like Python versus R, where we could talk Python versus R, but Python won. And in this case, SQL is the ascendant lingua franca, enabled by dbt's sheer ubiquity that shows no sign of letting up. So look, transformation is easier than ever. It's accessible to more people than ever. And the implication here is, just as data engineers shouldn't write EL pipelines, they shouldn't own the T either, or they shouldn't exclusively own the T either. What I often say here is, my background is data and growth. One of my growth and marketing mentors is fond of saying, marketing is too important to be left to marketers, right? And what that means to him is, the function of marketing is really important. It really should be pervasive. It should be something everyone eats, sleeps, and breathes in a company. And it isn't that hard to do with training. And so his first priority is, everywhere he goes, he builds a company of marketers. And in the same vein, transforming data into meaning, transforming data into value is too important to be left to only people with data in their title. And because of this, this diffusion of data transformation that's been enabled, we can actually expect to see, this responsibility being more diffused. Okay, next is rise of data ops. So data ops this is one of the areas I'm actually most passionate about, right? There's more tools than ever before, more transformations, and this means more metadata. If we do a good job of collecting, of structuring, of organizing, of presenting that metadata, then we can do a great job of helping people manage things like observability, manage things like monitoring their pipelines, monitoring for data quality, improving, creating new data models, right? And we have a host of new tools in the ecosystem that are helping us to do that. The implication here is also clear. Look, great, we have the diffusion of data transformation. We could spread out and expect functions throughout the enterprise to increasingly take on data transformation responsibilities. If we want that to happen, where we need to double down, the highest leverage point of focus is in investing in data ops, investing in metadata, investing in the servicing of that metadata, the collecting, transforming, and representing of that metadata. Okay, metric semantics layer. So this is also a rich topic, could be a whole talk in itself. I'm not gonna cover it into much detail. I can't do much justice here. But the way I think about it is, a semantic layer maps data to semantic abstractions. What are kind of the core dimensions and measures, and how should we talk about them? What names should we give them? And the metric layer is a layer of abstraction on top of that that takes some of those core dimensions and measures and maps them to higher order metrics, higher order business facts. The semantic layer simplifies data exploration, data modeling, right? This is, I think LookML is the classic example of this, right? Where it facilitates things like drag and drop SQL generation because of how the semantic layer has been constructed. And the metric layer is a click above that. Where great, I can use the semantic layer to construct metrics, but there's different ways I can construct those metrics, and I'd prefer for usability to have a single canonical, single source of truth representation of those metrics, and so the metric layer simplifies reporting. And the implication of this is clear. If we want to see more self-serve data consumption, right? Self-serve data consumption is this perpetual white whale. Most data teams, most companies haven't really realized the promise of self-serve. And there's a lot of reasons for that, but historically it has also been the state of the tooling. Just slapping a semantic layer in Looker is not going to self-serve make. And we've seen that. We've learned that lesson very clearly in the past 4 to 5 years. If we want to see more self-serve data consumption, the focus needs to be on the high leverage metrics layer, which is really coming into fore these days. And we expect great things in the next year, as well as continuing to develop innovations on top of the semantic layers that already exist. Last is democratization of science. Okay, so this is, look, science use cases are, clear in value, more standardized and productized, and they've never been easier to train, test, and deploy, right? When I say clear in value, I mean, there was so much hype. Again, we can go back to 2016. What did the world look like in 2016? There was so much hype about data science, and I think that hype has settled. Right? We've realized where the value is and where the value isn't. We realized, in large part over the past 5 years of trial by fire, what kinds of use cases produce value and what don't, and where we do see value, right? The kinds of classification models that produce value, the kinds of experimentation and A/B testing that produce value, the multi-arm bandits that create value, where we've seen the multi-touch attribution that creates value, where we've seen these very clear use cases, those have increasingly become standardized and productized, and we can give those now safely to the hands of folks that are maybe slightly less specialized. And where we want to train new models, right, whether they're in those kind of canonical set of use cases or venturing beyond, it's never been easier with supporting infrastructure to train and to test and to deploy those models. And the implication here is clear. Citizen science, as I call it, is easy and safe. It's something that we can now turn more people into data scientists without the training of data science, without worrying as much as we did historically. Profit is pretty safe, for forecasting, and this wasn't the case, a generation ago, right? A mere 5 years ago, but it is now. So these 6 forces in the modern data stack, as I see them, they really divide into 2 categories. On the one hand, processing data, right? Processing data is easier, but it's not just easier, it's also higher value because of things like the centrality of the data warehouse, right? Low touch ingestion, the rise of data ops, the diffusion of data transformation, all of those things make it easier to manage data. But because of the centrality of the data warehouse, it's now more valuable to do so than it ever was before. And getting value out of data when it's processed on top of that warehouse is also easier than it ever was before. It's easier to build self-serve experiences, and it's easier to self-serve, whether that means self-serving on the analytics side or the operational side through kind of the metrics and semantic layer, or the DSML side through the democratization of science. That's gotten easier than ever before as well. Okay, cool. So what does this mean for data teams, right? We've talked about the modern data stack. We talked about kind of how to reason about, these kind of key forces and what they might imply. So what does this mean for data teams in practice? So to start, we can just take a step back and look at the classic data functions, right? Classically, we can be a little reductive and say, look, there's basically 3 data functions, 3 core data families. There's data engineering, there's data analysts, and there's data scientists, right? Data engineers, they own that kind of data management lifecycle, right? How do we process data? How do we ingest it? How do we move it from one place to another? How do we manage the knobs and dials on the systems that store and persist and present data. Data analysts, heavily focus historically on things like BI and reporting, and where possible, ad hoc analyses, reporting, data pools. And data science has historically been a little bit hand wavy, and it's been kind of these advanced use cases, these advanced quantitatively specialized use cases, statistical applications, economic applications, mathematical applications that go beyond things like reporting. And the punchline here for us is that those six forces, and the punchline for this conversation is that those six forces lead to a breakdown of each of those functions. And we can start with science. So the standardization and enablement of citizen science that we just talked about allows data scientists now to specialize, right? And we start to see this in the industry already. The notion of data science, well, data science as a word is extremely overloaded. And we see that title receding, and we see the germs of what's going to follow, which is essentially a bifurcation into research science and MLE, where MLE is, hey, we're doing those specialized applications, but we're actually full stack, and we're taking them all the way to application, to productionization at scale, right? We're focused on scalability and performance and low latency, and we'll realize that as we expose our data science products as services. And research science, where, hey, we are going to go ever deeper. We are going to push the boundaries. It's great that we've identified as an industry, a set of use cases where companies can get value, but we're going to go deeper, or we're going to look for long tail value that has yet to be productized, right? And so we start to see this bifurcation of data science. This is how we are bifurcating data science at Flexport, and it's how I expect more teams to bifurcate, given some of these trends we see in the MDS. On the data analyst side, things like the metrics and semantic layer and the emergence of the metrics and semantic layer, as well as that democratization of science, means that we can also give data analysts clear paths to focus, right? At Flexport, we see this as a BI analyst track, and a data analyst track. We can call it data analyst 2.0, right? Where the BI analyst, yes, they're focused on reporting, but there's more to reporting now than reporting, right? There's more to reporting now than just owning that tertiary data pull layer, or picking bar charts over pie charts and customizing them. Now there's a metrics layer to build out. Now there is a semantics layer to design, and to develop and to own and to govern. And for us, the bifurcation of data analysts look like specializing, elevating the importance of that metrics and semantic layer. And on the other side, on the data analyst 2.0, expanding the scope of analysis qua analysis, right? Because we have those kind of specialized, democratized use cases, science use cases now in the hands of more people, empowering data analysts with a separate function to do things like use profit for time series analysis, or use anomaly for anomaly detection, and to unpack the implications thereof, to really focus on higher order consultative work with business partners, to reason about the data strategy for those domains, to think about things like not persisting metrics in a metrics layer, but to think about metrics design and a metrics strategy for their business partners. So this is the bifurcation we've seen. And again, clear reflection of MDS trends, of the MDS forces, and what we expect to see more of in the coming years. On the data engineering side, and this is really where we're going to zoom in, better tooling frees up data engineers to focus on what I think of as platform capabilities, right? To focus on making data easier to use. And the bifurcation we've seen here is that data engineers split out into essentially data platform engineers that are building really tooling to make data easier to use, and analytics engineers that are building the other capabilities, the kind of the non-tooling capabilities that make data easier to use. Think modeling and standards and governance and what have you. And this is this is where we really focus. So the modern data family, at a glance, we started off with essentially these three kind of classical functions, and for us at Flexport, it now looks more like this data family of 6 functions, and this is the kind of the canonical data family that we expect to see more of in the coming years. But where we want to focus for the remainder of this conversation, the next 10 minutes, is on a single function, and that single function I want to focus on is analytics engineering. So there's a couple of reasons for that. So taking a step back, why do I want to talk about analytics engineering? Well, look, we only have so much time. I could unpack the implications here for every one of these 6, but the data eng family is really where data teams need to grow, right? And one of the implications of how the modern data stack and the 6 forces of the modern data stack are shaping the data industry is that where teams really need to invest is in that lower plank, right? In that data eng family, data platform engineering and analytics engineering. Why? Well, I mean, quite trivially, everyone on this call has surely seen this hierarchy of needs, but data teams rarely reflect the hierarchy, right? If we were to leave everything about the modern data stack untouched, which we'll talk about in the next slide, if you just look at this hierarchy, data teams that I see throughout the industry have lost sight of what this hierarchy really means, which is that 80% of this work really is, below learning and optimization, right? It's below the analysis and science, and it's really focused on data transformation. Where then should 80% of our resources be? It should be in folks at that data platform engineering and analytics engineering spaces, right? But that's not how teams are organized today. That's how we are shifting to organize at Flexport, but that's not how most teams are balanced. The other way to look at this is that the 6 forces that we've talked about, they form a hierarchy as well, right? I basically look at ingestion, this bottom layer. I look at ingestion as essentially a solved problem. I view it as a commodity. Fivetran may not agree, but I view it as essentially a solved problem at this point that is en route to commodification. What isn't a solved problem are the 5 layers above. And the 3 layers above, the 3 layers that I have listed here in purple, are enabled by these 2 critical MDS forces: the diffusion of data transformation and the rise of data ops. It's those 2. It's realizing the value of those 2 forces that allows us to realize the value of the 3 forces up top, right? So we know data engineering is at the base, at the foundation of the hierarchy of needs, right? And we also know that given where the modern data stack is trending, given these kind of 6 forces, if we want to realize the value, if we want to realize the increasing value, the delta in value from these new 3 forces, we really need to lay down the foundation for harnessing the value from diffusion of data transformation and the rise of data ops. So what does it look to do? What does it look to do this? What does it look to realize that value? Well, to me, it looks like these 4 things. Number 1, data models are accurate, relevant, complete, timely, and consistent, right? And this is really a notion of data models are high quality. Number 2, that data models in the ecosystem, in the warehouse, in the lakehouse, are comprehensive, right? They span all the meaningful business logic that we would need to have span to be able to answer our business questions. Number 3, data models are easy to use properly and they're tough to use incorrectly, right? A measure of usability. And number 4, that data modeling tooling and standards are actually diffused throughout the enterprise, right? It's not enough to actually it's not enough to install DBT. We need DBT to be usable. We need standards to govern DBT so that folks throughout the enterprise can actually engage with that modern data stack force of diffuse transformations. So what does it take to realize that vision? Well, I think it takes 4 things: a data modeling center of excellence, right? Folks that define standards for how we approach modeling, well-governed data contracts, the guarantee that contracts are consistent between data producers and consumers, and they're non-collusive, right? That when we say the word user, we mean the word user throughout. In the same way, if there are discrepancies, we know where those discrepancies are. We can explain them, we can document them, we can track them. 3, data stewardship and custodianship. We need people to be accountable. When I say data stewards, I mean people that are accountable for data quality and expressivity. And when I say custodianship, people that are accountable for data compliance and things like data privacy, throughout the ecosystem, whoever contributes to data pipelines. And lastly, we need product management and product marketing for data models, right? When I say product management, I mean, hey, anyone can design a data model, but we need folks to design that design with the long tail in mind, with the future in mind of how do we develop data models as a product. And when those products change, what we call data products internally at Flexport, how do we do that data product marketing to cascade those changes, to handle the change management throughout the enterprise? And this is the mandate for analytics engineering, right? And the notion that I have for analytics engineering is very different than what you may hear elsewhere. I think DBT's notion of analytics engineering is basically analyst that write SQL, right? That is decisively not how I see analytics engineering. I see analytics engineering as driving these four criteria, right? I see analytics engineering as doing what's on this page here: defining and enforcing global modeling contracts, global modeling standards, owning that kind of data contract process, guaranteeing data security and quality, designing models and supporting change management of those models, and supporting MDM and semantics, right? In short, I see analytics engineers as the meaning makers of an enterprise, right? Data models carry meaning, and the value out of data models is dependent on the meaning that's expressed in those data models. And we need meaning makers in enterprises, in all enterprises, to really own what that process looks like and ensure that it's set up for success. And that's where I see the role of analytics engineering. So what might this look like in practice? So I'll close with a kind of a concrete example. Again, these are all implications of the current state of tooling, the current state of the modern data stack. What this looks like in practice for our tech teams is this flow. For data in the tech lifecycle at Flexport, the triggering event to animate all data activities is the PRD, right? A product manager creates a PRD and says, we are going to make these changes to the product. When that happens, there's basically some combination of three data side effects, right? Either there's new data that's being created by this feature that we're releasing, there's old data that's being mutated, or there's new business questions that we're going to ask of the data as a result of this new feature. Those data side effects are then carried through the rest of this process. So starting on that third piece, right? Hey, what are the new business questions we might ask about this? That's where things are now handed over to product analytics. And this represents product analytics as that kind of data analyst 2.0 notion, right? Where this data analyst 2.0, this product analyst, is really in charge of, hey, PM, at the outset, before we write a single line of code, before the PRD is considered for engineering requirements, let us work together and let me lead the definition process of here are the business processes that are implicated, and here's the business questions, here's the KPIs, the KFIs, et cetera, et cetera. That is an integral portion of the PRD, and the PRD cannot be shipped, cannot be actioned on without that analytics requirements that's now led by this data analyst, right? Once that happens, that PRD is taken along with these analytics requirements to domain engineering to basically create an ERD, right? An engineering requirements document as part of the engineering requirements process. And here's where the analytics engineers come back into the fold. The analytics engineers, as part of this engineering requirements process, have a data requirements process. As part of the ERD, they come up with what we call a data design document. And the role of the data design document in this life cycle is to take those three data side effects, right? New data created, old data mutated, new business questions being asked that data, and to handle them at every layer, to design the internalization of those side effects at every layer of the stack, right? So the analytics engineers then take those and say, based on these requirements, this is how we should design your persistence models upstream engineering team. Here's how we should design your data contracts. Here's how we should implement client-side and server-side taxonomy, client-side and server-side telemetry, and under what taxonomy. Here's how I'm going to evolve the data contracts from a design perspective in your domain for this feature. And when the data ultimately propagates into Snowflake, here's how we need to model those data, to represent data products that the rest of the enterprise can use, right? That then goes and is instrumented and validated, and ultimately that analytical data modeling, that last step of here's how we actually model the data in that warehouse, right? That very high leverage step, that is now a shared responsibility, right? The analytics engineers here were, as is befitting of their role as meaning makers, the analytics engineers are really the architects, right? They are the data designers. They are designing what data looks like at every layer of the stack. And yes, they are also often writing the data pipelines, but they needn't be the only ones that write the data pipelines. Again, data transformation is too important to be left to data people alone. The data design doc specifies, hey, here's how we should structure data, but then anyone can follow that design doc and actually go through and realize and reify those data designs into models in practice. That then goes upstream into BI development. Here I've consolidated, the bifurcation of data analysts. As we discussed, there's kind of BI analysts that own the metrics and semantic layer, and there's data analysts that do more analysis for analysis. You could imagine there being kind of this broken line here in product analytics, where that first step in analytics requirements is really owned more by data analysts, and that latter step, the BI development, is elevated, right? This is not trivial work. It's elevated to its own function of BI analysts that focus on that semantic layer, focus on that metrics layer, and carry that metrics layer through to now decentralized, democratized analysis by all parties, right? By product managers, by design, by engineering partners, by product analysts themselves. And then the cycle renews, right? The cycle goes back. We start with the PRD again, and we anchor. But the key to all of this is really the anchor to this is in this context, that analytics engineer, right? That analytics engineer that drives the design of data, that keeps this wheel spinning and pivoted upon that data design document, that sets the vision for and the data strategy for in this case, a single product team. So anyway, that is I think we're right about a time. I'll close here. And I think my message here is go hire more AEs. Thank you. But look, we could have a broader conversation. What we talked about here was, look, the ideal data team, in companies depends on these three types of contexts, right? The business context, industry context, the tech context. Really, what we should be thinking about, what we should be reckoning with as an industry right now, as a data industry right now, is what the changing tech landscape means for us, and the changing landscape manifested as this modern data stack for me is these 6 forces. And those 6 forces really highlight, I think more than has been clear in the past, really highlight the importance of these foundation layers, right? If we want to realize the value of things like standardization of science and the metrics layer and the centrality data warehouse, what we need to focus is on meaning making, is on data transformation, is on supporting the diffusion of that data transformation, and it's on building out data operations. And to do that, the key here is analytics engineering, and to some extent data platform engineering as well. So with that, happy to take questions, and in the future, happy to unpack the implications for other functions too, right? Because it's not all about analytics engineering. The reason I picked analytics engineering is because I think it's the team that is most deeply implicated by these tech changes, but it's not the only team, right? And we can certainly unpack the changes for what does this mean for MLE, what does this mean for data analysts, what does this mean for BIEs, et cetera, et cetera. But with that, I'll turn the floor over to you, Mark.
Cool, thanks, Abhi. This was great. I especially like the structuring of the six pillars that you showed, and later you went and put them on a vertical scale and give them different color codes as to what's foundational and what gets built on top, and that resonated a lot with me. Cool. Awesome. Time for questions. We have one question that got in the Q&A section. I'll ask that. If other folks have questions, please raise your hand on Zoom or type in Q&A. Abhi, the first question is from Santosh. He was asking in the context of metric layer, as in who will maintain the metric layer? Do you see that being the business side or the IT side of a domain?
Yeah, so the actual tooling itself, right? The infrastructure itself. I'll talk about in the Flexport context. What we use as the metric layer, we have our own kind of proprietary implementation of a metrics layer we call Flexpats internally. who builds FlexStats, who maintains FlexStats, who specifies kind of the metadata that must be encoded into FlexStats, into that metadata layer, who sets the standards. That is the data function, right? I guess you would call it IT here, per your question, but that is the data function. And, for us, that is data platform engineering, right? Again, data engineering, if it's bifurcated into basically data platform engineering and analytics engineering, that is data platform engineering that kind of owns that infrastructure, that tooling. Then, who actually encodes metrics into that metrics layer? I think it's early days for democratizing the encoding of metrics to the rest of the enterprise. I think we still need, strong data power users and stewards that have the power to sanctify, certify certain metrics as source of truth. And so for us, that is data analysts or business intelligence analysts. So the business uses outputs from the metrics layer, but they're really building on top of metrics that have been encoded by, in this case, primarily business intelligence analysts.
That's great. Another question from Jay is asking, does Flexport use any third-party software product or platform for any of the data science area?
Yeah, we use a variety of tools. So, I listed SageMaker. We do use SageMaker. I think we're looking to continual right now. Most of the applications, the data science applications here at Flexport have historically been what I might call OR applications. So a lot of what we actually use is constrained optimization solvers and solver servers. But yeah, a variety of tools that are also variably owned by data platform engineering.
Cool. I'll actually pile on Jay's question and ask, Avi, if you could share a little more about the current data stack. I know the focus is the team, but if you could share a little more context in the current data stack at Flexport, how that's evolving, what pieces do you think are fitting and working well right now, and where you see that going for you?
Yeah, I think we're a poster child for the modern data stack, right? So we have a lot of what you'd expect. We have Snowflake, we have DBT as the standard for all data transformation. We use a variety of the standard tools for replicating data, so Diffusion for replicating application databases, Fivetran for replicating third-party data sources, et cetera, et cetera. We use, of course, the standard for data catalogs. We use Stemma at Flexport, and that is pretty standard set of tooling. I think where we are really excited right now, and Mark knows this because I've talked to Mark a lot about this theme, is metadata. Right, metadata is absolutely top of mind for me. DBT is not really a metadata management system. We can force the issue and turn it into a metadata management system for at least the data transformation in the lakehouse. But a real metadata management system for us would look like, how do we collect, structure, and represent and transfer metadata between systems across all of the different layers of data, right? Across our transactional systems, our analytical systems, our reporting systems, and how do we make it easy for people to manage and update that metadata, and then surface it in things like data catalogs. So that's a topic that's top of mind for us. It's where I'd love to see the MDS actually invest more. I think it's the biggest opportunity that hasn't been explored. So hopefully that answers, Mark.
It does. Thank you for sharing. Cool. I wanted to see if anyone has any other questions before we wrap it up. All right. In that case, thank you again. Oh, Jared has a question. Pardon me. Jared, would you like to ask your question?
Yeah, I'm curious if you have any thoughts on the type of personas that succeed in the type of AE role you're describing. I think we've landed on something relatively similar, and really looking for people who take a focus on like the contract and design and product side of it rather than the messing around in DBT piece. And so I'm just curious, like within and outside the organization, how you've handled just putting the right people in that spot in terms of either hiring or moving people from adjacent roles?
It's a really, really great and important question because this is a relatively new function, right? Even data engineering itself was a relatively new function in the grand scheme of things, but then analytics engineering is even newer, and then this notion of analytics engineering is basically newer still, right? Because this is not necessarily how Fishdown and DBT, et cetera, talk about analytics engineering. Look, the way I think about it, personas, I think is a great way to put it. The way I think about it is when we think about hiring, there is basically a library sciences persona, for lack of a better word, that I approach, where it's people from kind of other disciplines, cross-functional disciplines. That library sciences is actually a great discipline that really focus on things like the cataloging and representation of information models. We've had some great conversations with folks and some successes by pulling folks that have really thought about information models, but from a very different lens, from a very different vantage point. So that's one. Another is folks on the engineering side, a little bit more senior, that are on the software engineering side, that are interested in architecture. I think I always say that we say software engineering is basically model view controller, right? We talk about things like fat models, skinny controllers, but no one ever focuses on the model side, right? The way we train and incentivize and reward software engineers is primarily on things like modern JavaScript frameworks and being able to plug DevOps holes and working with the alphabet soup of integrations across major cloud platforms. But it isn't really the art of data modeling. But there are more senior software engineers, I think especially, that have come around, have seen where the bodies are buried, have learned what the pitfalls are of kind of ignoring data models, and have come back to really taking a data model centric approach when they reason about what they need to build. So I think that's kind of the second persona that we found some success with. And then the third persona is folks with deep domain knowledge. Things like PMs, if you will, or potentially even analysts. That have deep domain knowledge that they can translate into and want to translate into the domain model, right? What should the domain model be for a given transactional domain? So those are some functions we've had some success with, and beyond that, we're also just trying to train people, analytics engineers, from different stripes, people that used to be called data engineers, into thinking about data modeling first and foremost. One of the books I used to, several years ago, one of the books I used to give data engineers most often was, the Agile Data Warehouse Toolkit, right? Or potentially, designing data-intensive applications, or something like that. The book that I now give the most often to data engineers is Domain-Driven Design, right? One of the two domain-driven design books that everyone recommends, and that's crucial because I want analytics engineers to start thinking about the domain model of transactional systems, and not just in terms of this kind of these downstream, dim and facts and star schemas, etc. Does that make sense and resonate, Jared?
Yeah, absolutely. I actually like the sourcing out of people with software engineering backgrounds. One of the funniest experiences I've had lately was talking about pushing data back out of our warehouse to activate it in downstream applications. Mm-hmm. And our internal software engineering partners, the first thing they asked for, even talked about it, was data contracts. It's like already naturally, like you said, senior software engineers naturally think that way. That was really helpful. Yeah. Thanks.
Great. All right, Mark, anything else?
Some people are asking the name of the book that you mentioned.
Oh, Domain-Driven Design. Domain-Driven Design. There's two books if you Google around. There's like two recommendations, a slightly older one and a newer one. You can try on either.
Cool. We're at the 5-minute remaining mark. Avi, thank you so much for coming and sharing with us.